In the last few videos, we talked about how you can take a polynomial and divide it by another polynomial using a division process very similar to what you learned back in middle school when you were first learning how to divide numbers. That process is called long division, and in this video, we're going to learn a shorter, quicker way of doing the same process that kids tend to like. Between the two methods, both will accomplish pretty much the same thing, but kids tend to like the second method better overall. Before we get into that though, I have a little bit of vocab that I have to go over. Last video I focused pretty much on how you do the problems, but here's an example that I just made up ahead of time. If you want to practice it to verify for yourself that you know how, that's great. You don't have to. Basically, what happened in this problem is that we took a situation like this. We had our polynomial, and we divided it by x plus 4, and my answer to this was x minus 9. So we took the inside guy, divided by this part, and we ended up with this answer. So that's what I wrote over here in green. Now, another way of writing this picture, if we were to take the guy on the bottom here, and notice, by the way, there was no remainder, so I didn't bother with that. It goes in evenly. If we were to take the bottom on the right side here and multiply both sides by an x plus 4 to kind of get it out of the denominator, times x plus 4, we end up with x squared minus 5x minus 36 equals x minus 9 times x plus 4. So basically, if we multiply those things together, we get x squared minus 5x and then minus 36. So we can say a vocab word here that x minus 9 and x plus 4 are both factors of the original quadratic. So that is a factor of the x squared minus 5x minus 36, as is this guy over here. Since we can multiply them and they go in evenly, there was a remainder of 0, that means that we have factors of our original. If we had done a problem where we had a remainder, maybe there was like a little, I don't know, 4 down here or something like that, the original thing we divided by would not be a factor anymore because it doesn't go in evenly. But if we have a situation where it goes in evenly, we call that thing we divided by, and our answer for that matter, a factor. So we have our two factors right here, and we talked earlier on in the year about the idea of a root. The root is the value of your factor that actually makes the thing equal to 0. So if I had, for example, in my factor up there, my factor was x minus 9. Taking just one of the two pieces right over here. The root to that, if you picture this thing was set equal to 0, the root is going to be x equals 9. So 9 is the root, whereas x minus 9 is the factor. In my other part, I had x plus 4 equals 0. That x plus 4 is my factor. My root is x equals negative 4. That vocab is going to come into play on our next slide here, where we learned about a new division process called synthetic division. And I have the 3 rules written out right here. I'm going to read through them, and it really is best to see via example, but I'm going to just quickly go through these here. 3 things. Synthetic division is going to use the roots instead of the factor. So in our last problem, we were dividing by things like x plus 4, for example. That would be the factor that we used. If we're using the root to that would be a negative 4. So we would use negative 4 for our division. You'll see how that plays out in a little bit. The 2 steps here, numbers 2 and 3, are why kids tend to like this process better than long division. First of all, it uses just the coefficients, so we're not going to be dealing with any variables. No x squareds or x to the thirds or stuff like that, which is appealing. And the best thing of all is that when you do synthetic division, you're going to be adding instead of subtracting. Adding tends to be easier for people than subtracting because you'll make silly mistakes all the time when you're subtracting numbers, especially when you get negatives involved. So let's actually hop into an example here. And I had that same problem from before worked out so you can see what the answer is supposed to be. This time, though, I'm going to show you how you do it with a process called synthetic division. So we're going to get a similar setup to before, but this time I'm going to do an upside down division box. So instead of having my normal typical division box like this, I have my upside down. And on the outside, instead of putting the whole factor right here, we had an x plus 4, we're going to put just the root to that piece right there. Now if it's x plus 4, my root is a negative 4. So I'm going to put a negative 4 on the outside right here. When you're putting your -4 down, notice I did kind of make it a smaller number up top like this. Basically, I'm leaving room for 2 lines of numbers. You'll see that in a little bit. So I kind of made my -4 a little bit big. I'm actually going to go ahead and erase it and make it a little smaller, just so it's not confusing later on. Typically, you put your roots up here. And along the top row, I told you I had 2 lines, or space for 2 lines of numbers. That top row is going to be the original problem that I'm dividing by. But instead of putting that whole line on there with the x's and all, I'm just going to put the coefficients. So I have a 1x squared there. I'm going to put a 1 along the top. I have a -5x. I'm going to put a -5. And I have -36. Put -36 right here. If I had been missing a term, just like before, you'd put a 0 in there. That doesn't change. But no variables, just the coefficients. So we're ready to actually start with the problem. The first step in synthetic division is always the same. You bring down your first number. So I'm going to leave that space blank and bring that 1 down all the way to there. So you just bring the 1 down. The answer is going to be written along the bottom right here. That's where our answer is going to go. After you bring down your first number, you are going to take your root, the number on the outside, times that 1. So you're going to multiply, and whatever you get from that, you're going to put it over here on the next available spots. So as you guys know, -4 times 1 is -4. And once you get those numbers, typically when you have numbers underneath each other, like maybe, I don't know, here or here, you subtract them in regular division. The nice thing about synthetic division is that we're going to add going down. So I'm going to do a -5 plus 4, and I'm going to get -9. Once you get that number, you do the same process again. I'll switch colors here. Take my -4 times this number. I know I have arrows going everywhere. Sorry, I'm trying to change colors to make it a little easier. And whatever I get, -4 times -9 is positive 36. I put that right here. I add 1 more time, and I get 0. So that's the end of my problem. I need to analyze what happens here. First of all, the rightmost number, the one on the far right, the last thing you write down, is the remainder. Typically, I even have kids put it in a little box like this. So this is my remainder. I had that. And the rest of these pieces here are the coefficients of my terms, and they go in descending order. So typically, if I have my remainder all the way over here on the right, the next guy over is my constant term, which is just my plain number, followed by my x term. If I had another term over, I don't, but if I did, it'd be x squared. The next term over would be my x to the third term, and it just keeps working its way up like that. So I'll erase this last few that we don't need, but that's the basic idea. So, my answer for this one is x minus 9. 1x minus just plain old 9. And if you notice, it's exactly what we got over there. So it works. I'm going to walk you through another example, and then I'll give you a chance to practice one. Let's talk about one more together for now. A lot of writing up here. Again, I worked it out beforehand with just normal plain old division, so you guys can see how that goes. But I want to do this problem with our new method of synthetic division. The piece I want to divide by is the x plus 2. So I want to put my roots of -2 on the outside. Set up my little box right here. And I'm going to copy my coefficients. I have a -2. I have a 5, a -1, and a 2. So once I get to there, I'm going to go ahead and drag down my first term. That's always the case. You drag it down. Then I do -2 times -2, which gets me a positive 4. Put that here. I add those two numbers, and I get 9. Oops. 1 second there. Okay, so I have my 4 right here when I will add it. I get 9. -2 times 9 is -18. -1 plus -18 is going to be -19. -2 times -19 is 38. And in this one, I do have a remainder. Once you get your answers here, you need to analyze what happens. Farthest right number is your remainder. We have a remainder of 40 on this one. This is my constant term. This is my x term. This is my x squared term. And if I had another one, it'd be x to the third, and so on. So my answer is going to be -2 x squared plus 9x minus 19. And with the remainder right here, it's the same way as before. You put remainder over thing you divided by. And don't do like -2. Don't get tricked into doing -2 or x minus 2 because of that guy right there. In the original problem, we were dividing actually by x plus 2. And that stays the same. It's over x plus 2. So there's our answer. I have one more problem in this video, and you can either opt to do it yourself, and I'm going to have you pause it, reveal the answer like before, or you can just hear me out if you want to see one more worked out. So here's our last problem. Go ahead and write this down, and I'm going to reveal the answer in just a second. But if you are doing this on your own, do not forget the promise you made to me in the last video with missing terms. Don't forget about that. The actual answer, though, is right there. So if you guys got that answer, beautiful, you are done with this video. But if you didn't, or if you you just want to see me do it, I'm going to work through it real fast. The nice thing about synthetic division, these go a lot faster when you get used to them. Once you get the hang of them, I can do them faster and in less space. So it's really nice and compact. Got x plus 3 down here. My root is -3. It seems like my roots of this one have all been negative. That will not always be the case. It's just by chance. My coefficients, though, 1x to the 4th. I do not have an x to the 3rd term, so I put a 0 there. Then I have 3, 1, and 4. Carry down. I got 1, -3. I got -3 right here, 9. Going really fast through this one just to prove a point that it can be done a lot faster. When you get used to this method, it does really make your job a lot easier overall. Ooh, -3 times 35, that's going to be a negative, nope, positive 105. So you get 109 for your remainder. We got remainder, constant, x term, x squared term, and x to the 3rd term. So if you actually compare that with the coefficients to what I have written right on up there, you see that that is your correct answer. That is synthetic division.